By the time you finish listening to this episode of Preview of Tomorrow, 13 new house fires will have started somewhere in the world. This means that every 87 seconds, a house fire ignites, causing an average of $12 billion of damage every single year. And while traditional sprinkler systems are effective at battling large, fast-growing fires, they are significantly less effective at tackling slow-growing fires, which can quickly produce lethal volumes of toxic smoke. In 2021 alone, house fires and wildfires accounted for 1.6 billion tons of carbon dioxide released into the atmosphere. We are in a desperate need of technology that can more accurately identify and extinguish fires before it is too late. Hello, I am your host, Mike Lake, and in today's preview, I will be talking with Yusuf Mohammed, Chief Design Officer of Plumas, a solution that is revolutionizing the fire suppression equipment industry by designing a smarter, more efficient way of detecting and suppressing building fires.
Innovation, resiliency, discovery. Join Mike Lake, President and CEO of Leading Cities, as we explore the technologies shaping the possibilities of our future with a preview of tomorrow.
Hello and welcome, Yusuf. Thank you so much for joining us today on Preview of Tomorrow. And once again, thanks to all of our listeners and viewers for joining us. I'd love to introduce you to Yusuf Mohammed. He is the Chief Design Officer for Plumas, a solution created to reduce the number of deaths and injuries caused by fires through the provision of intelligent fire suppression equipment. Now, Yusuf, I'm curious, how is it that you were inspired to get into this particular field of work?
Well, that takes me back. So I was studying innovation design engineering at the Royal College of Art. And for my group project, they ask you to solve a real world problem. So me and some colleagues, we went down to the local fire brigade and we said, we'd like to come up with an idea that makes an impact in an emergency situation. And we got talking to them and they highlighted a couple of things. They said, first and foremost, that fire extinguishers in certain buildings was actually a fire risk because untrained firefighters were trying to fight the fire instead of escape the building. And the other thing that they said was that they used water mist to put out fires. And they would do that by turning the hose to the mist setting and applying small droplets onto the base of the fire to really bring down the temperature. And it was those two insights that led us to kind of trying to think about new ways to tackle fires.
Well, so that's really interesting. And you kind of just blew my mind with this. Both points. I mean, first of all, that fire extinguishers could actually be a hazard. Although now that you've explained it, it makes perfect sense. Although to all of our listeners and viewers, mental note, if there's a fire burning, get out first. Don't worry about that fire extinguisher. But for the second issue, the idea of water misting a fire, I mean, it's just so counter to what I envision, these massive hoses, flooding a building. This is really interesting to me. And I would imagine that there's also heightened risk of a firefighter, no? To have to be close enough to the base of a fire to mist it versus stand from afar and drench it.
Yeah, well, they can do both. I mean, they perform different functions within the room. One of the main reasons a firefighter would use mist is if they're trying to control the temperatures. It has a real benefit. And what happens is the small droplets turn to steam. And in doing so, it displaces the oxygen that would otherwise feed the fire and gets rid of a lot of the heat. It's a kind of a proven method of addressing fire that isn't really commonly known. Not a whole lot of people know about it.
Wow. So, and let's be honest. There's a huge risk of fires, right? I mean, like we're all exposed to it every day in your home, in your work, in your school, in wherever you may be. At any moment, a fire can break out for any number of reasons. I know I said in the intro that every 87 seconds, somewhere in the world, a
Mm.
fire is starting in a building. Um, so this is actually a problem that affects all of us, right? I mean, and nobody wants to be the victim of a fire, and I don't mean that in terms of death, but certainly nobody wants that. But also in terms of just loss and whatnot. So well, first of all, what can we know about this problem? The threat of fires that we might not know already.
Okay. Well, what I learned when I was doing my research and trying to come up with this, with a new idea, was that firstly that we have one main solution in buildings. Everybody knows it. It's the fire sprinkler. Interestingly, that's been fundamentally unchanged for over 100 years. So it was actually invented by a man called Thomas Grinnell in 1882. And the glass bulb ceiling mounted systems that you see all around the world, it's very, very similar to that design. But because we've got this one really common solution, we kind of accept the problems associated with it. So first and foremost, they cause, if you know, a lot of water damage when they activate. If you've just watched Die Hard, you'll get the sense of how much water they deploy when they activate. And because you've only got one solution, and the types of buildings, the types of people that you're looking to protect vary so widely, it just means that there is a gap. So, for example, if you're in an area that's susceptible to freezing, you have to insulate all your pipes and it becomes expensive. And they can be very difficult to install if you've got limited water supply. So we've got this one solution that's really, really commonplace, but the situation, the criteria has to match that in order for it to be cost effective. So what we really wanted to do was come up with an alternative that has different attributes.
So, as is often the case with our guests and on Preview of Tomorrow and the solutions that they've created, is the biggest threat is not always the problem that is being addressed, but really the status quo. And so I love the fact that you've challenged this status quo after almost 150 years, really, to create something new, something innovative, something more effective, and not just accepting all of the unfortunate realities of an existing solution. So tell us more about what you've created. How does it work? What is it and how does it work?
Okay, so we've created the first electronically controlled domestic fire suppression system. I've actually got one with me here, so I'll just show you it. Rather than mounting.
And for those listening, we are looking at a very simple device. Yeah.
Yeah,
it's a little box.
A little box, a wall-mounted plate, and we've got an infrared sensor that targets the hot spot within the room. It can measure the temperatures in the room, and if it identifies a location with a heat signature that you just shouldn't see in the home, it forces a blade of water mist into its direction. So in doing so, it uses 10 times less water. It can operate 2 to 14 times faster, and it's much, much easier to install because it doesn't require a tank or significant amounts of water in order to operate. Our kind of main idea and one of the reasons why we think it can be so useful is that sprinklers are mandatory in a number of different regions in the world, whether you're in California or in New York. New build properties require sprinklers, but they are disliked, and our product gives you an opportunity to address some of these kind of challenging buildings. We've been selling our system in and around the UK for the last 6 years, and we're really excited about moving over to the US.
Well, that is very exciting. I mean, you mentioned the 10 times less water. They often say that with fires, in the end, the water does more damage than the fire itself in many cases. I mean, 10 times less water is a significant reduction of losses in a situation like that. Am I understanding that correctly, or am I making an unfair assumption?
No, no, you're completely right. You can fill a bathtub every 3 minutes when a sprinkler activates. Not many people, it's a really significant amount of water. And we've had properties here in the UK and the US where not just that flat gets completely drenched and has to be sort of dried out, but the flat below it, because the water has to go somewhere. So our method really gives you an opportunity to minimize that consequential water damage associated with their activation. And we're really excited about the conversations that we're having with insurers, because obviously they have a similar interest in reducing the sort of claim damage
Sure.
associated with such systems.
We've been talking a lot about the water damage, the fire damage, but in terms of particularly human life, it's oftentimes the smoke that's the real threat. How does this address that issue?
Well, what you can do with using an electronic trigger is you can actually trigger significantly earlier, whereas a traditional sprinkler has to wait for the ceiling temperature to go above a threshold to activate. Because our scanning head monitors a change in temperature over time, we've trained our algorithm to identify even slow-growing fires. So as a result, it can operate when the fire's smaller, and that reduces the amount of smoke and toxic gases which fill the place. So it's particularly useful and one of our main customers here in the UK is looking to protect properties that might house vulnerable individuals, perhaps people who can't self-evacuate in an emergency situation. And that added time is so key in trying to reduce the risk.
So you touched on this a little bit, but I want to dive a little deeper. For anyone who's listening or watching this and is like, wow, I really need to upgrade my fire protection. What does it mean to actually install such a solution?
Okay, well, when we were designing the product, we wanted to make sure that it could be retrofit easily into existing buildings. When we were talking to those firefighters all those years ago, they said to us, well, look, sprinklers are particularly cost-effective in new build housing, because what they do is they put all the pipes up when they're sort of constructing the walls. But if you have an existing building, then you have to create that space. You've got to probably bring down the ceilings, and you might even have to upgrade your water supply. So when we were designing the system, we said it had to work within the existing framework within the house. So take less water than a power shower and be easy to retrofit. And we do that by using things like flexible hosing to our wall-mounted heads. So as a result, you can apply it to an existing building without sort of the expense that you might have with a more conventional system.
Wow, and so this is something, I mean, when I think of the sprinkler systems, at least here in the US, I'm thinking, those are multi-unit buildings, large apartment building type office buildings, things like that. But you don't see a sprinkler system in a single family home. This is just as easy to install in a single family home?
It is, and you're exactly right. When sprinklers were first designed, and before they were really used in residential buildings, they were born for factories. One large pump cover a massive space. But our system is it's almost modular in how it's set up, and therefore it lends itself much better to smaller spaces, things like accessory dwelling units or modular build, because it has a different economy of scale.
Wow. So, my mind is spinning here with both the realization that we're woefully underprotected in my own home, but also just the seemingly ease with which we can upgrade to a solution like this. So is this something, by the way, does it require professional installation?
It does. In the UK, we've got a network of accredited reseller installers. And these are these are companies who are authorized to install our equipment. They've gone through our training. And we're going to look to build a similar network as we enter the US. This is something that we are planning to do at the moment because we're just concluding our certification, almost equivalent to our FDA approval for the US. And we want to replicate the same model which we had in the UK over here in order to get it into more homes.
Wow. I truly have so many more questions, but the time is nearly up. So I have to ask you the question I always end with, which is imagining 10, 20, 50 years from now, the world is using Plumas technology for every fire suppression system in any building or factory or whatnot. What does that mean? What does it mean for the individual? What does it mean for the community? What does it mean for the world at large? What do you see the impact of Plumas?
Okay, well, I mean, our mission, our vision is to reduce the number of deaths and injuries from fire and get better outcomes for people and for property. We think that we can do that because by having an alternative solution, we can make fire suppression cost effective in buildings where otherwise it wouldn't be. And by reverting or using electronic triggers, we can operate earlier and reduce the risk of smoke and heat for occupants. But where things get really exciting is because sprinklers are mandatory within certain buildings. We also are really keen to explore the idea of using in the installation of our system to enable smart buildings. So for the very fact that we've installed a heat sensor in our head to tackle the fire, well, you could use that same sensor for all sorts of other things. So perhaps you use it to control your heating or to identify people within an emergency. So we're really excited about our mission to reduce deaths and injuries with fire, but also making sprinklers desirable because they can give you more value beyond just fire suppression.
Well, Yusuf, I can't thank you enough because the fact of the matter is you're saving lives. And that's, I mean, how can anybody, thank you enough for that? That having been said, I also want to thank you for taking the time to join us here today on Preview of Tomorrow. For anybody who's listening and wants to learn more or get in touch, what's the best way for them to learn more?
No problem. So the company's name is Plumis, spelt Plumis, and the product is Automist, Automist. Drop it into Google. You'll find our website quite easily. We've got a lot of videos on YouTube, so you can actually see the product. It really comes to life when you can actually see it addressing a fire. And you can find us in all the usual places as well, Twitter, LinkedIn. That's all good as well.
Perfect. Well, with that, Yusuf, thank you so much again for joining us today. We look forward to your success because your success means more safety for all of us. But thank you for being part of Preview of Tomorrow.
My pleasure. Thank you for having us, Mike.
And thank you for tuning in to this episode of Preview of Tomorrow. Listeners like you are essential to advancing our efforts to drive resiliency and sustainability for all. I ask that you give us a rating on Apple Podcasts or whichever streaming platform you prefer. Your feedback helps us to grow and share these brief previews of what life in the future can be. In addition to thanking our guest today, I want to thank Peter Roy and Demetria Bridges for making this podcast possible. If you enjoyed this episode, please subscribe and encourage others to also join us each week in previewing the possibilities of Tomorrow.
Preview of Tomorrow is brought to you by Leading Cities, a global nonprofit driving resilience and sustainability for all by unleashing the potential of the world's cities. Join them at leadingcities.org.